In this video, we're going to be talking just a little bit about how respiration is regulated. It's primarily regulated by adjusting a couple of different factors. First, it can be adjusted by regulating your ventilation rate, so that's your breaths per minute. And it can also be regulated by adjusting the depth of ventilation. So for every breath you take, how much air do you take in? How much do you expand your thoracic cavity? And there's really two levels of regulation that we're going to touch on. We're going to talk about actually a couple of different levels of neural regulation and briefly how chemical monitoring of the blood plays into respiratory regulation. Because as you remember from the previous video, changes in the chemistry of the blood are directly related to how effective respiration is. The first level of neural regulation of ventilation deals with the respiratory rhythmicity centers. These centers, they establish the basal rate and depth of ventilation. So under typical normal conditions, how quickly are we breathing, at what rate, and how deeply are we breathing. These respiratory rhythmicity centers, they're located in the medulla oblongata, and there is a dorsal respiratory group, the DRG, and a ventral respiratory group, the VRG. The dorsal respiratory group takes in information from chemoreceptors and baroreceptors in the lung. So chemoreceptors in the blood and baroreceptors that detect the degree of stretch of the lungs. So they respond to how much your lungs are already expanding. The ventral respiratory group, the VRG, drives forced breathing, so it drives a maximal inhalation. These both modify the basic rhythmicity. There are pacemaker cells in these rhythmicity centers that drive the basal quiet rate of respiration. The DRG and the VRG modify that rate based on input from chemoreceptors in the blood, input from stretch of the lungs, and signals telling us to take a forced breath. Let's talk about those chemoreceptors for a second. They're all based around the amount of carbon dioxide in the blood and how that relates to pH of the blood. Arterial pressure of carbon dioxide is actually the most potent respiratory stimulus. Most of you probably think that you breathe when you need oxygen, but it's actually more physiologically correct to say that you breathe when you need to get rid of carbon dioxide. Carbon dioxide is much more of a force in driving ventilation than oxygen is. So what happens is if you are not respirating well, if you are not removing enough oxygen, you get accumulation of oxygen in the arteries that decreases the pH. There are chemoreceptors in the medulla oblongata and chemoreceptors in your arteries, in the carotid and aortic bodies, that detect the increase in hydrogen ions. So they detect that increased acidity of the blood. These chemoreceptors send signals to the respiratory centers, and those respiratory centers, they control the rate of respiration. They increase both the depth and the rate of breathing. All right. This response to carbon dioxide, the fact that carbon dioxide is really the central stimulus for respiration, that is why hyperventilation can actually inhibit respiration. So when you are hyperventilating, you're blowing off too much carbon dioxide, and that can actually inhibit respiration. Okay, back to the brain. And now we're at a second level of control. So we've talked about the DRG and the VRG, but now what controls the DRG and VRG? In the pons of the brain, you have two groups of neurons. You have the apneustic and pneumotaxic centers. And these guys are what control the DRG and VRG groups. The apneustic is providing continual stimulation to the DRG. Continuous stimulation. It only stops when the lungs are fully stretched during forced breathing. So the apneustic centers continuously stimulate the DRG, but then they shut off to prevent overinflation and potential damage to the lungs. The pneumotaxic centers adjust the DRG and VRG, and they regulate, so the DRG and VRG set the basic pace of breathing, but the pneumotaxic centers take information from the higher brain centers and can adjust that basic rate. So think of when you're scared and your breathing rate increases, or when you're holding your breath. What you're actually doing is you're telling your pneumotaxic centers to either increase breathing or stop breathing. So this is really just a quick basic introduction to some of the levels of control over respiration. You should be able to talk about the following, how they contribute to regulation of breathing: the respiratory rhythmicity centers, the DRG, the VRG, the apneustic and pneumotaxic centers. And you should also talk about the relationship between blood carbon dioxide levels and pH, and talk about how this chemical adjustment helps regulate ventilation.